Alright, today we're going to be learning how to graph a quadratic or a parabola when it's in vertex form. Personally for me, I think the vertex form is a lot easier to graph in once you kind of get the hang of how to kind of identify things. So the first thing we're going to do is the anatomy of a parabola. Just look at how a parabola is usually set up. So usually we have a parabola, but it's right in front of us. All right, we have our vertex, all right, which is either a max or a min. In this instance, it's a minimum, so this is our vertex. It's symmetrical, so whatever we ever do to the left, it's also the exact same on the right. So typically, to get our points, if we were going to have 3 points on each side, how you get these points is you go over 1, we go up 1. To get the next point, we go over 2, up 4. And for the third one, we go over 3, up 9. All right, because when we do this, when you have a parabola, it's usually y equals x squared. All right, so when I plug in 1 squared is 1, so I go over 1, up 1. When I plug in 2, 2 squared is 4, so you go over 2, up 4. All right, and when you plug in 3 squared is 9, so when you go over 3, you go up 9. And that's the same for the left, so once you have it to the right, you know what to do to the left. So we're going to use that kind of over 1, up 1, over 2, up 4, over 3, up 9 to kind of help us do a lot of these things here. So I do this little part right here on my paper quite often over to the side to kind of help me figure out how I'm going to graph it from there. The great thing about vertex form is going to give you the vertex right away, so that's always my first starting point, is where to graph my vertex first, and then using my a value find my other points. So let's do an example here together. All right, what we're going to do here is we're going to be graphing multiple functions. So what I would love for you to do is grab a couple different colors. I usually do like black, red, and then blue. So I'm going to start with black. All right, and that's usually just my plain old function of y equals x squared. So I'm going to graph y equals x squared. Now, technically, this is actually still in vertex form. We can identify all the transformations. So look at there, the a value is 1, so that means we're not going to stretch or shrink it at all. It's not negative, so there's no reflection. Okay, there's no numbers like inside a parenthesis or outside the parenthesis, which would indicate the horizontal or vertical shifts here. So our vertex is at 0, 0. So that's my first point here, 0, 0. Using the anatomy, I know. The anatomy is we go over 1, up 1, over 2, up 4, over 3, up 9. Since there's no a value, we're still going to do those exact same things. So I'm going to go over 1, up 1 for my first point. You can repeat that on the other side as well. I'm going to go over 2, up 4. 1, 2, 3, 4. Repeat that on the other side. And I can go over 3, up 9, so 4, 5, 6, 7, 8, 2. And repeat that on the other side. Okay, so right there I have my parent function of a parabola. All parabolas we do are kind of a transformation or a variation of this one right here. All right, so we're going to slowly kind of reduce like how we look at these. So I'm going to grab red. I'm going to do the next function in red here. So my next function is going to be y equals negative 2x squared. So first off, identify the transformations. That negative means it's a reflection of the x-axis. So instead of opening upwards like this one does, we're going to flip it over the x-axis so it's going to be opening downwards. So we're going to have a maximum point here. That 2 right here signifies that it's going to be stretched. So it's going to be a little bit skinnier, not as kind of wide there. And we do that by multiplying it by 2 there. So here's what I do is over the side, I'm going to make my little anatomy again. Over 1, up 1. Over 2, up 4. Over 3, up 9. Now, since we have an a value, I'm going to take all these values here, that 1, 4, and 9, and I'm going to multiply all of those by my a value, which is negative 2. So 1 times negative 2 is negative 2. 4 times negative 2 is negative 8. 9 times negative 2 is negative 18. So what this tells us to do now, it says we're going to go over 1 and down 2. We're going to go over 2 and down 8. We're going to go over 3 and down 18 to make that parabola. Now here also you look at, there's no, the vertex isn't going to change. There's no horizontal or vertical shifts. My vertex is still 0, 0. For my first point, it says we're going to go over 1, down 2. And then it says we're going to go over 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. And duplicate that on the side. Now, we can't really do our over 3, down 18 because we kind of run out of room. But as long as you have your 5 points, you're good to go. So here's our problem. Look, it has that reflection, so it's facing downward. All right, and it's just a little bit skinnier than the previous one. All right, let's do one with a little bit more complexity here. So we're going to graph this quadratic function. It's y equals 3 times the quantity x minus 1 squared minus 5. So there's a lot of things kind of happening here. All right, the first thing I see is we've got this 3. All right, so we know that's going to change our vertical stretch or shrink. We're going to shrink it by a factor of 3, so it's going to get a little bit skinnier. So it's going to be even skinnier than this red function we just did. All right, the x minus 1 and the minus 5 actually tell us our vertex. I'm going to graph this one in blue. That's a purple. Okay, so I know that my vertex, okay, it's going to be positive 1, comma, negative 5. All right, which means because this tells us we're going to the right 1, and the minus 5 tells us we're going down 5. So I'm going to plot my vertex first. 1, negative 5. 1. So I have that. From here, we're going to utilize that 3 and we're going to figure out all of the other points. So in order to do that, I need to graph my anatomy and kind of go from there. So my anatomy is over 1, up 1, over 2, up 4, over 3, up 9. Now we're going to be changing, remember, these items right here. And how we do that is we multiply it by the a value. Remember, our a value is 3. So I'm going to do 1 times 3, which is 3. 4 times 3, which is 12. 9 times 3, which is 27. We're going to graph that all from our new vertex. So with the new vertex, I'm going to go over 1 and up 3. 1, 2, 3. Oops, I got some extra points there. And I can replicate that on the opposite side. So the opposite side of here, I go to the left 1, up 3. Next one's we're going to go over 2. So over 2, 1, 2. Up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can erase all those little dots real quick. All right. From there, we can't really do the over 3 up 27. You would very rarely get that over 3 up, whatever it might be. So from here, I connect the dots and I can make my parabola. So notice it's a little bit skinnier than the last one. All right, and our vertex has shifted down over 1, down 5. Last one here, let's do this in red. All right, we've got y, or f of x equals negative 1/4 times the quantity x plus 2 squared. Now this one has a lot going on here. First thing I notice is this negative, so that means it's going to be reflecting down, so it's going to be opening downward. It's going to have a maximum point. The 1/4 is a vertical shrink, so that means our graph's going to be a little bit wider than it has been. The x plus 2, that tells me we're going to the left 2 to start off my vertex. Since there's no number over here, we have no vertical movement. So first off, I would figure out what my vertex is. I would say my vertex, we're going to go, it says x plus 2, so we're going to go to the left 2. There's no number at the very end signifying that it's going to be a vertical shift, so it'd be just 0. So my vertex is at negative 2, 0. So negative 2, 0, right here. From there, we're going to make my anatomy and kind of figure out where we're going from that point. So over 1, up 1, over 2, up 4, over 3, up 9. We're going to be changing again these values here, 1, 4, 9, by multiplying them by that negative 1/4. So 1 times negative 1/4 is negative 0.25, or negative 1/4. 4 times negative 1/4 is negative 1. All right, and then 9 times negative 1/4 is negative 2.25. So we got some decimals here, so it's not going to be the prettiest graph ever, but we can kind of maneuver our way there. What this signifies here, since we have over 1 and then negative 0.25, we're going to go over 1 and down 1/4, then over 2 and down 1, and so on and so forth. So if I start here, I'm going to go over 1, down 1/4, which would be somewhere around here. I can do that on both sides of my graph. Then I'm going to go over 2, 1, 2, and go down 1. This one I can actually graph that third point there, so I can go over 3, 1, 2, 3, down to 0.25, 1, 2, 2.5. Oops, that last point was not a good one. There we go. So from here I can make my parabola. So you'll notice it's a little bit wider than the previous ones we've been doing. All right, it is reflected down. All right, and it did shift over